Hey guys, in this video we are going to perform the hyperparameter tuning of a deep learning model just like we do it on a machine learning model using sklearn library. So that means we are going to make use of sklearn library to perform the hyperparameter tuning on a deep learning model which has been created with TensorFlow. Alright, so guys, this is an advanced tutorial. So if you are new to the deep learning, please make sure that you check out the deep learning video series first, and then you can revisit this video so that you can get the more idea about what is happening over here. Okay, now coming back to the topic. So in order to do this hyperparameter tuning with Scikit-learn, we'll make use of Keras wrapper. So this is the official documentation page of tf-keras wrappers.scikit-learn.keras regressor. Okay, so we are going to make use of this Keras wrapper of Keras regressor. Now the reason that I'm going to use this Keras regressor because I'm trying to build a regression model. Now I'm going to build that model and I'm going to place it inside this wrapper, which is a Scikit-learn wrapper. Now once I wrap it up inside this particular Keras regressor, I'll be able to make use of sklearn's various methodologies that we already have and use it to perform the hyperparameter tuning. So let's see how we can do that. Now to be able to do it, here I'm just going to take care of necessary imports. I'm importing my TensorFlow library, and from TensorFlow I'm importing my Keras. And in order to perform this task of regression, I'll import California housing, which is present inside my sklearn datasets. And I'm going to make use of train test split to perform the split between train set and the validation set. And then I'm going to import my standard scaler to perform the scaling operation on my data. Now, once that is done, I'm going to import my data set. So this will take care of getting the data set object and then performing the split into train set and the test set by referring to this housing data. And then I'm going to split again. So I'm going to split my training set again into training set and my validation set. All right. So this will take care of necessary splits and getting the data. And once that is done, I'm initializing the standard scalar object and then I'm performing the fit transform on my training data. So this is very important, guys. I always repeat this. So we perform fit and transform on my training data, and on the basis of learning that I'm going to get on my training data, I'll use that particular learning to transform. Remember, it's only transform on my validation as well as my test data. Alright, so this is the same methodology that we are going to follow no matter what the application that we are writing. So we perform fit transform on my training data set, and we only perform transform on my test or validation data set. Alright, so this will take care of necessary basics that are required for us to start working. Now, in order to wrap it up under this Keras regressor, the first and the foremost requirement is I should be able to create a function which will actually compile and return me a Keras model. Now, in order to do this, I have created a function. So this is the function which is called as build model. And this build model says by default number of hidden layers is 1, number of neurons is 30, and learning rate is 3 into 10 power minus 3. And the input shape is 8. So these are the default inputs my build model is expecting. Now inside this function, I have initialized my model as sequential, and then I have added the layers. So keras dot add dot, and then I have specified my input layer with my input shape like this, and this input layer is connected to my dense layer on the basis of number of hidden layers that I specify over here. Hence I mentioned as for layer in range n hidden. And then I'm going to add individual layers, and by default I'm setting it to be equal to ReLU activation function. And in the final layer I've specified a dense neuron, so dense single neuron. So that's what I have in my output layer. All right, now once the model building is complete, I'm defining the optimizer. In this example, I'm just using this simple stochastic gradient descent optimizer, and this is followed by compiling my model. So I'm compiling my model, I'm specifying my loss as mean squared error, and the optimizer is stochastic gradient descent. And this function build model, once the compile operation is done, this is returning me a model. So with this, the prerequisite will be satisfied. The prerequisite is creation of function which would return as a Keras model. Now once the model is built, see, as you can clearly see, this model is a ready-made model. So when I call this function, it would automatically return me a model for me. Now if I want to wrap it up, so I can directly wrap this up inside this Keras regressor. So here I mentioned as Keras wrappers.scikit-learn.Keras regressor, and I have specified my function which would return this model, and I have set it equal to this Keras reg. You can check out the documentation as well, guys. See, for the build function, we have to specify. So build function is the important parameter that we have specified over here. So this is my build function, that is build model. Now once that is done, so in order to enable the better training of my deep learning model, so I'm defining the callbacks. If you're not aware of what these callbacks are something which we actually specified during the training of my deep learning model, which would automatically track how the model is performing. Alright, so in my example, that is in this cell, I'm using the early stopping as well as model checkpoint. So in our previous video, we have learned as how we can make use of model checkpoint. So if you are new to this, I highly recommend you to check out that. But in this example, I'm making use of model checkpoint and the early stopping, where these are the two callbacks. So early stopping help me to perform early stopping, and model checkpoint helps me to keep a track of my validation accuracy. And so in this example, it is validation loss. And on the basis of this validation loss, I'll be saving only my best trained model. Alright, so once I've defined my callback, I'm just going to perform the fit. Now while performing the fit, I'll call the fit method just like we call any deep learning model. So here I mentioned as Keras regressor.fit, xtrain, ytrain, and I have mentioned my epochs as 100, validation data is expired and yvalid, and callbacks, I have specified my two callbacks which I had defined earlier, that is model checkpoint and early stopping. And then we can start the fit. So in my scenario, I have already performed the fit, and we could see, so the system has proceeded and it is actually performed the fit, and by the end of 100 epoch, so we could see that validation loss was 0.34323. Okay, so that was the best found. All right, and this was the best loss value, guys, 0.34323. all right. Now if I want to get the score, so the score is nothing but the score that I would get from my linear regressor. So the reason, because I'm going to refer this score as something as a measuring criteria. So the score is nothing but the coefficient determination of prediction. The reason that we are going to call this score, because I'm using the scikit-learn wrapper. Hence, we are going to make use of this score as a criteria if I'm performing any hyperparameter tuning using my sklearn. Okay, so here it says score, it is going to return the coefficient of determination of prediction. Now in this example, the score is 0.37. Okay, so this is what my data is conveying. So if I have the value closer to +1, then that would mean it's a very best model. And if I have the value which is closer to 0, it means it's a bad one. And I can also have negative as well, because the model can be arbitrarily worse. This is the score which I'll be using as a criteria when I'm performing my hyperparameter tuning. Alright, now obviously if I want to do any prediction, I can just call the predict method and do it, guys. Okay, so we have created a model. Now this model is a wrapper which is inside the scikit-learn, and we have seen how we can perform the training. Now let's see how to perform hyperparameter tuning. Now as you clearly know, when we are performing the hyperparameter tuning on a deep learning model, the parameter space is limitless. I can control many things over there at once. So we are going to make use of randomized search CV method. So I'm importing this randomized search CV, and I'm defining my parameter distribution like this. So I'm defining my number of hidden layers as 0, 1, 2, 3. So these are the 4 values that I want to test out, and the number of neurons can be between 1 to 100. And I'm specifying my learning rate as like this. So these are the parameter distribution that I've given. And now And now to find the best parameters, I'm making use of this randomized set CV, and inside this we'll specify the model as a first argument, that is KRS regressor, and I'll specify my parameters as this param distributions, and I'm mentioning as what are the number of iterations, and CV, that is cross validation. Okay, so CV is equal to 3. And then the next step is I can just directly call the fit. Just observe the results, guys. I'll be sharing the code to you in the description. You can check out at your end as well. Alright, so you can also add the model checkpoint as well to make sure that you are logging those models as well. Okay, now once the training is complete, this will take a while for the training to complete. So by the end of the training, so if I access my best parameters, so these are the best parameters. The running rate is 0.007166. Number of hidden layers is 3, and the number of neurons in each layer is 70. So these are the best parameters that has been found by my system. And if I look at the best score, the best score is in negative. The reason this is a negative because as I've said already, so this is a randomized set CV, and the range that I've given is very big. So since it's very big, so the system try to find its best score. So the next strategy can be something as, okay, so if this is the best score, now I can just select that area and give some little less range and do the same activity again and again. Alright, so once I have got the best model, I can just assign to a variable and I can directly perform the fit. So in this way, we can perform the hyperparameter tuning of a deep learning model using sklearn library. I hope this video has been helpful to you. If you are new to us, please subscribe to our channel, and if you are new to deep learning, do check out our deep learning playlist that is in our channel. I look forward to seeing you next time, guys. Thank you so much. Take care.